Greetings and welcome to another lecture in Introductory Psychology. Now this one covers the descriptive methods of research, okay? These are not experiments. Now experiments, remember, give you cause and effect. These are also known as correlational methods because they give you correlations. And correlations, of course, simply tell you that two or more variables are connected, but they don't tell you how. I've recorded lectures on experiments versus correlational methods. You could go take a look at those. This basically is just going to list a few types of correlational methods that are commonly used in science, particularly in psychology. Now, the first of the correlational methods is one you have almost certainly done yourself. It's a survey. It's a questionnaire. It's an inventory. You are asked questions about something and you answer them. If you have never taken a survey, I would rather want to know what rock you just crawled out from under, because pretty much it's impossible, at least in our culture, to go through life without taking surveys. Whether they are official surveys, ones you've taken in school, teacher evaluations, or whether they're surveys that you might take for fun. Now, surveys are delightful. They have a lot of advantages. One big advantage of surveys, whether written surveys or speaking with people one-on-one or however you want the questions answered, one big advantage is that you can get a huge amount of information from a huge number of people in a very small period of time. Conceivably, for instance, if I was at a school with 10,000 students, I could probably figure out a way to send a survey to all 10,000 students in a week, and assuming they all answered, which is a big assumption, I could then have 10,000 subjects with who knows how much data in a week. So they're great for that, which is why they are done so often. They're also useful for getting information on topics that you may not be able to study using other methods. For instance, very often when researchers are interested in human sexual behavior, they do a survey, which is, of course, better than doing things, well, maybe not, but it's different, easier than doing things like dragging subjects into a laboratory, wiring them up, and having them have sex in the laboratory, which, by the way, two researchers in the 1960s, last names Masters and Johnson, did, and got a lot of very useful information. But it was also suggested that perhaps the sexual behavior they was watching was not exactly equivalent to what people would have in the privacy of their own homes or wherever. So what would you do instead if you wanted to? I mean, you could also go and peek in people's windows, but then you'd get arrested. So instead, what do? You ask people questions. You give them a survey. Now, the good things about survey, as I just mentioned, is you get a lot of information in a short period of time on things that might be difficult to study otherwise. The biggest, baddest news about surveys, however, is, well, one of them is people lie. Let's say we have that aforementioned sex survey, and let's say that the researcher is asking about certain interesting sexual practices that are perhaps frowned upon in that particular culture they are in, and the researcher says to the subject, well, have you ever done this? And maybe the subject actually does that particular behavior every day and twice on Saturdays. There's a matinee, of course. But are they necessarily going to tell this person that? No, people lie. People lie for lots of reasons. They lie to make themselves look better. They lie to give the researcher what the researcher wants. They lie to screw around with the researcher. Lying is a problem. Another big problem, of course, is if you're researching something that people might not remember. If I asked, for instance, what sort of behavior you like to do when you were in kindergarten and on the playground, I can't remember last week, honestly. So you're going to remember what you did in kindergarten? No. So you might come up with something, reconstruct something, which is not technically lying, but it's not exactly telling the truth either. And you also need to be very, very careful about the questions. The idea of science is to investigate and find out what the world actually is, and not to find out what you think the world is, or what you think the world should be. And how you phrase the questions can really make a difference in the answers that you get. It's part of the reason why every election season you have the Republicans and the Democrats asking people, the same people often, questions on the same topics and getting entirely different answers, because it's all about how you phrase them. So what do you need to do when you're making up a survey? It's kind of a pain, because the researcher needs to make up the survey, Give it out to people, see the results they get, see if they need to change questions, change the order of questions, change the wording of questions, modify questions, throw questions out, bring questions in. And of course, once you've done that, you have to test it again. A lot of surveys will be pre-tested multiple times before they're even used to collect actual data. And even at that point, it's possible that once the researcher does the research, they find out that the survey needs to be tweaked again and done again, and we're back to the circle of scientific method. So it's not easy to make a good survey. It's very easy to make a bad one. And the internet is full of bad surveys if you want to play with some of them. Another correlational method is the case study. Now, case studies are used to research things that we cannot ethically, for instance, create. Case study is studying one person or one event in great detail. Okay? Usually these are naturally occurring events, naturally occurring people. For instance, if you want to study serial killers, you can't really go and create your own serial killer in the lab. Well, you might be able to, but that wouldn't be ethical. So what do people do to find out about serial killers? They go talk to serial killers once we've caught them. Okay? Which also means, by the way, that we may not know everything about serial killers because not all of them get caught. And so we only can learn about some of them, and we're back to how science does its best. So or for instance, let's say that a person wants to study a catastrophe. We can't create catastrophes in the lab, but we can run around and find catastrophes that have happened and study those. For instance, Superstorm Sandy, Hurricane Sandy, made landfall in southern New Jersey, devastated the New Jersey coastline, devastated much of New York City. And I will bet you that along with along with the volunteers who were helping the people after the storm, there were also a whole bunch of psychologists and sociologists looking for data. Now, case studies are difficult because you have to learn everything you can about the topic. If you're studying serial killers, you can't just go and chat with one. Okay? You got to talk, for instance, to their family, talk to their friends, talk to their teachers, talk to their employers. Look back at their childhood, look back at their adolescence. You have to discover absolutely everything you can about them in the hopes of being able to find connections. And even then, you may not be able to find them. Profilers, for instance, at least in theory, are able to look at a crime and say, well, the person most likely to do this crime is this, that. And the problem with profilers is they're only a little more accurate than psychics, and psychics are not accurate at all. Because very often, the person is not who you expect them to be or what you expect them to be. Even though we say from case studies this is what they should be, trust me, humans will behave however they want to. Humans don't listen to the rules. Part of the reason why a lot of, chemists and physicists look at psychology and go, that's not a science. Science is when you have A and B and you put them together, you always get C. Well, in humans, of course, it ain't necessarily so. So case study is learning everything you can about a topic, about an event, about a person, about an illness, which may or may not give useful information in the long run. We also have the various types of observation. Okay. Naturalistic observation is named exactly what it is. You're going to watch individuals in their natural environment. You want to know how kindergartners play on the playground? Go watch some. Get permission first, by the way, unless you like getting arrested. If you want to know how animals behave in the wild, don't watch them in a laboratory. If you want to know how human beings behave in a certain situation, go and watch them. Now, first of all, this is difficult, okay? It's not as easy as it sounds. I've been in observational studies because you have to see what is actually happening, for one, which is not easy, and you also have to make sure that you're not changing the behavior. There's a lovely thing called the observer effect. Human beings and other animals, for that matter, are extremely good at knowing that when they're being watched. Let's say you're sitting in the cafeteria with your friends, and you notice that there is somebody over in the corner table who is watching you very intently and scribbling down notes every now and again. Are you going to behave naturally and normally? I'll bet not. You're probably going to do one of these things. You're going to walk over to them and ask them what the hell are they doing. You're going to leave. You're going to behave differently. You're going to behave better. You're going to behave worse. That is not natural behavior. So there are ways to get around this. One of the ways, of course, is to use miniaturized cameras, and we're seeing that more and more and more. There are other ways. Simply become part of the scenery. If the researcher was always sitting at the same table for 2 weeks, you'd start to ignore them because they're always there. And if after 2 weeks they start to watch you somewhat surreptitiously and write down notes and aren't obvious about it, it's quite possible that you won't notice it. But they also have to be careful what they see. Human beings see what we expect to see. We remember what we think is true. And if a scientist thinks that this is going to happen, the odds are that's what they're going to see. Let's say that we have this scientist, and the scientist's hypothesis is that kindergartners on the playground are incredibly violent brutes and spend all their time beating up on one another. And that researcher gets permission and goes to the playground and becomes part of the scenery and watches the kids. And of the 100 kids on the playground, 2 of them are busy beating the crap out of one another over in the corner, while 98 are perfect little angels. What is the researcher going to write down? Kids beat the crap out of each other during playtime. So in order to get away from this bias, usually you have to have more than one observer, several observers in fact. I was involved in an aggression study with rhesus monkeys. We sit and watched a colony of rhesus monkeys, and we wrote down every bit of aggression they had, which wasn't difficult because they're violent little buggers. And so, but the thing is, we had 4 people in the room. 2 people watched one half, 2 people watched the other half. And we had to make sure that the 2 people in each half saw the same thing, reported the same thing. Another study I was involved in was looking at the interaction between mothers and babies when one or both of those individuals were deaf. How they did this is they videotaped a wide shot of both of them and a close-up of mom, close-up of baby, and people, would have 6 or 8 or 10 people watch the video, write down what they saw to make sure everyone saw the same thing. So it's not as easy as just going out and watching things and going, yep, that's how it is. Okay, so you have to work around that. There's also laboratory observation. Now, you're not going to get purely natural behavior here, but very often you will get behavior that does indeed relate to the natural world. A lot of what we've learned about learning and memory, for instance, a lot of what we learned about learning in particular was done with rats in a laboratory. Some of it purely observational. Okay. Now, does this mean that it was purely natural behavior? Probably not. But you know something? Even though it wasn't purely natural behavior, we could still apply it to the real world. Those sex researchers, Masters and Johnson, okay? It's quite possible that some of the behavior was not what we would find in the real world. But for instance, they spend a lot of time looking at the physiology of the behavior. What happens in the body? The physical reactions. Was that observation as accurate in the lab as in the wild, as it were? I bet you it was. Now notice with all of these, what are you doing? You're observing, you're describing behavior, but you're not ruling out all other variables except for the potential cause. There's anything that could be causing these behaviors. Anything. That's why it's correlational. That's why it's not cause and effect. Because to get cause and effect, you have to rule out, you have to control for absolutely everything except the potential cause. And in correlational research, in a survey, in a case study, an observation, you don't do that. You can describe, you might even be able to predict. I'm not so sure about explain.